will be soon because they have asked us to upload the recording. It will be coming soon.
Okay, thank you, sir.
Actually, you let
Sir,
me know like start recording. I forget to forget.
for numerical practice, which source we follow?
Actually, we people making the PPT for the questions. There we used to put many questions and send to you like that. And they have also started the like I think test series in that portal.
Yes, sir. Sunday, 2 to 5 p.m.
So that way
Yes,
also
yes,
they
yes.
are working. Okay,
Okay,
then
sir.
these questions we can take after the class also. I think.
Sir,
Hello?
if hello, sir, if a test series answers is available, it's helpful, sir.
Oh, I'm not getting. What are you saying?
For test series, after time is over, if a solution is also
Oh,
available,
solution are
then we
not there,
can.
huh?
No, sir.
Okay. That I will.
The solution of some question given, sir, in YouTube. They attach YouTube link and just click on YouTube and you get the solution.
Some
So there are
Where it available?
solutions for only
what?
only
Where it available?
YouTube.
Which
Okay, that we
where can
will see.
access?
Okay, first we will solve this. Hmm?
Hello, sir. Sir, in question, uh, there has been said that pressure varies linearly with volume. Is there anything linked to that, sir?
Actually, this is only linked with this here to in finding the delta x. Here, what we considered like pressure and this delta x. With
No,
how much?
sir, but
Uh-huh.
uh, he said that pressure varies linearly, so then we can take that the pressure is equal to in the form of mx. Pressure is equal to cv. C is some constant, like where it makes a relation,
Okay.
linearly relationship, sir. Can we solve like that, sir?
What same thing will going to happen? Just to see. Now we will find the work. Now there you will see like okay that is happening. Okay.
There will be some difference occurring, sir, in our solution to that, and the way I explained like this and
Because
the
here we
answer we
what we
got
have to
looks
find like net heat transfer you are going to find now. Here
yeah, yes, sir.
what to for from the first law of thermodynamics what is the heat transfer with the first law delta Q is
du plus
equal to
dw,
del U
change in
plus
internal energy
W
plus work done.
net work done. So this delta U we will be getting from where this steam table we will get delta U final position is 803. So what is the final U this 3668 right per kg.
Yes, sir, yes, sir.
And
Yes,
initial
sir.
one is how much this one. So what is the delta U here? Can anyone let me know? Like UF minus UI and don't forget to multiply mass here, okay? Because this is per kg, right?
Yes, sir.
Specific.
So calculate this and let me know what is the delta U. Try quickly because we have to finish second class.
569. 569.
Anyone?
569.4, sir.
So what is delta U? 569.4.
4
Next, two digits.
kilojoule.
Two digits you can take. Only this much is coming.
Sir, it's only to this.
Okay, fine. So now coming to the work, delta U we have got, and now we have to find like what is the delta W. So for delta W now what they have told here. Uh, now read this line. Now this will come into picture. Pressure varies linearly with the volume until final pressure is 500. Initial one is how much? 198.
Plus 198.
So let's suppose here we are going to write pressure and here we will write in the volume. So here we will say like 198.5. Okay. And here we will say like it is 500.
Excuse me, sir.
Yeah.
Can we find the heat by using polytropic formulas?
How you going?
PV, like P is proportional to V, no, sir. That is, pressure is proportional to the volume. So the equation will be PV minus 1, PV per minus 1 is equals to constant. So that the N is minus 1. So using that, we can use the
Okay. Which
polytropic.
formula are you going to use then?
We have polytropic work done. So similarly, we have a formula for polytropic heat. So
Actually, for what polytropic process is there? It is for the ideal gas, like that, na?
It is a saturated water vapor, no sir.
Uh,
It can act as a perfect gas also, no sir.
how water you can treat as gas? Water will come to now. Water will
Water
considered as
vapor. It said it stated that water vapor, no sir.
initially water vapor, na? Later it is not. You cannot say like it is vapor. Now you are not sure now. Some parts of maybe like some liquid also maybe there. You can never it is saying like it is saturated.
Um,
yes,
And
the
never
polytropic
consider
work.
vapor as means a liquid you can water in like for the pure substance there when we
no
will
sir.
take Rankine
It is
cycle.
no
Okay, na
sir. You
Rankine.
once open the table, sir. Once again.
Okay.
Uh,
One thing I want to
then
let you know, like never try to apply PV is equal to MRT this equation.
no sir.
Uh,
You can
what are
use
you saying?
MC delta T.
What are you saying?
Yeah, MC delta T, sir.
Heat transfer. Where you want to try to use MC delta T?
For finding the heat transfer in this process.
Eh,
The
we
change.
used to take MC delta T only when let's suppose you constant pressure process is there. Okay.
No. For water, no sir. I'm not taking constant pressure.
What value of C you
Specific
going to
constant
take here?
for you said if it is water, then we use 4.186 something. Then no sir.
No, this is only 4.186 where this when it is below the saturated level of water. Okay, only.
Yes sir.
But it is nothing in it may be in between or in somewhere in vapor also. We don't know exact condition yet here.
Yes sir.
So here what they have given like internal energy they have given. Okay, so first we have heat in basic first law of thermodynamics. How will go? Heat is equal to this and this, and for work done they have specifically mentioned like it will vary linearly with the volume.
Yes sir.
So only that way we are trying to go.
Yes sir.
So whenever they will say like it will provide the whole process. So what is the first initial volume here, and what is the final?
So initial volume 0.44593.
0.4.
0.44593.
Okay,
And final volumes are point 0.49618.
49.
618.
618. So let's suppose first point is here and second point is here. So now here we have to put like this is linear. So now for work done, what is the work done? Area under PV curve, right? Hello.
Yes, sir.
So we have to
Yes
find
sir.
the area under this curve. So we can also, if you know the this is the trapezium. If you know the formula for the trapezium area of the area under the trapezium, so you can that way also find. Otherwise, you can divide this into two parts. First one is this rectangle, and this one is triangle, right? Hello.
Yes sir. Yes sir. Yes sir.
Yes,
Huh.
sir.
So for the trapezium, anyone knows the formula? Work from 1 to 2, let's suppose.
So if we do h/20 a plus b.
So parallel side का sum multiplied by the length upon 2.
Okay, in the terms of the pressure, I will try to write. Means let's suppose this is 1 point P1 and here P2. Okay, so PIPF we will write. So here formula would be like PI
P1
plus
plus
PF.
P2.
Okay,
Yes.
PI plus PF and delta
Multiplied
V
by
means
V
PF
and
minus PI.
yes.
So all values I think we are having. This is in the kilopascal and it is in the meter cube. So this would be coming into the kilojoule. So how much it is coming?
10.50.
10.50. Okay, someone more?
Sir,
Mm-hmm.
sir, whether this work itself includes the piston work or it doesn't include piston work, it roughly says only PDV work, sir.
Piston works means what are you saying? Piston mass also there like that you are saying.
No, sir, sorry, sir, it's a spring work. Spring work. This work actually includes spring work, or we want to calculate the spring work separately, sir.
Actually, this will include.
This will include both piston work
Ha
and also spring work.
ha.
Okay, sir. Okay, sir.
So how much it will come?
So for my case, 17.56 was the answer.
17.8 came, sir, per minute.
1 minute. 17 point. How much you say?
17.8.
56. And for
Five
my case, 70.
17.54.
54.
Sir, sir, but if we do find work by integral PDV, then in equating P equal to some constant into volume, then sir, by that formula it's coming 10.5.
Sorry. What are you saying? Integral
Uh,
PDV.
Integral PDV and P equal to CV. C is a constant that is equal to P1 by V1.
Actually, here what is there na? You cannot say like it is okay. See that way you are trying. Huh? What value that way also we will try. Okay, 1 minute.
Okay, sir.
So this way exactly how much is coming? Because here directly it is answer you can get from here. I think.
17.56. And what's the answer?
Okay, then say we will take 17.56 close to that.
Sir, this is in kilojoule.
Kilojoule it will come because it is kilopascal and it is in meter. Because 17 it is coming right. 17.56. So work done is this and how much is delta U? This much. So what would the net heat transfer here? 569.4 plus 17.56. So what is the net heat you have to give?
587 point 69, 587.564,
Your
587.
answer is 586.
No.
0.96, sir.
It would be
586.96.
Okay. So this much heat you have to give.
Sir, I have a doubt.
Mm-hmm.
Sir, actually, if we multiply also, you will get this, no, sir?
What?
Delta work done, change in work done. If we multiply also, you will get sense.
Not getting you what you are saying.
No, sir, no, sir. No,
Sir,
understand.
actually, we discussed that TP and CV same for let us. It is same for an incompressible substance, sir. Like generally, we can take it as Q is equals to MC delta T.
Mm-hmm.
But for saturated vapor, is C is not constant, sir. We can't use that formula.
No. For liquid, it keeps on changing actually. Actually, it is not said anything like it is you take a ideal gas and nothing. So with till that point we cannot use that. Okay. Here it is liquid. There is specifically said saturated vapor. Vapor water means for water never you try to use ideal gas equations. Okay.
No, sir, but actually we took the conditions of saturated conditions only, sir, from the table. The T is the saturated temperature and P is the saturated pressure.
Mm-hmm.
Then it will be the saturated state. We can conclude that it is a saturated vapor state, sir.
For water vapor also never we cannot take as ideal, na. That's the issue. From steam table we used to take property there only.
No, sir. We came. No, sir. Here VG there, no, sir.
VG, huh?
VG.
Okay.
Actually, it means what VG means.
Okay.
It means the saturated
specific,
vapor state. Yeah, specific volume of the water vapor state at 500 kilopascal pressure at saturated temperature 803 degrees centigrade. So we have taken conditions for a saturated vapor state which contains a volume of 0.99 at pressure 500 at temperature 803.
Mm-hmm.
No, sorry, that's why I'm saying that it is a saturated vapor state because as we
It is superheated
assumed
state.
that
Okay, we consider that. Okay,
no,
fine.
sir,
Mm-hmm.
that's what I'm saying.
Okay, then what here you are trying to say? Take.
Oh, sir, you said that we cannot conclude the state. Mean it may be wet state or it may be
That
gas
I
state, no,
said
sir.
that
That's
time. It is vapor, but main thing is here. Someone is saying like with we will use like this ideal gas equations here. So that we cannot use. That I'm saying.
So here, specifically that constant was a change, na sir, with respect to temperature. Initial
That's
temperature,
what I'm
final
saying here.
temperature.
For the those we will consider like CP will not change. In many assumptions are there. So here no assumption we are trying to take. That's why.
Sir, actually not the ideal gas equation, but we can use it for incompressible substance equation. MC delta T. For water, C is 4.18, is
No, for
constant.
vapor it is not 4.2. No, that's what. Vapor it is not 4.2. Check it.
Vapor is compressible, bro. Vapor is compressible.
Vapor
4.2
with
is
pressure
for
volume rapidly changing here. You can see.
sir,
During wet
4.2
vapor
is for normal.
What?
during wet vapor state, the C is constant.
What is?
Specific heat, sir.
Okay. No, nothing. With in a wet condition. 1 minute. Let's suppose this we will take, and here C is not coming in picture actually. We will with steam tables we are using properties, and with the dryness fraction etc. we will try to find things here. Okay. Actually that steam table part and etc. I don't think we have discussed yet. So see, I don't think here we used to take any problem you are considering value of specific heat here, because here one column also we would be having of entropy here in real steam table, but here don't use, we have no use, so that's why we haven't took. So with that way we have to go with the entropy here, this way, this point you know entropy, this point entropy with value of dryness fraction. 1 minute. With value of dryness fraction x we will use to find the values here. Actually with not try not to relate this with the gaseous equations. That's what I want to say, because it's very confusing. Here you will get incompressible liquid, and in between liquid plus vapor, compressible and incompressible, both things would be there. Now you trying to try to use it like here you will get only gaseous state, but if you used you try using here, but properties keeps on changing here also, and same way you at some point of time try to use here, but that is not real case actually. Okay,
Sir, this question is from first law of thermodynamics, sir.
actually we have to use only that. Here you have to take only two values only that volume, specific volume you have to take from here, and this
Sir, what is the best?
internal energy of that initial and final condition you have to choose, means you have to know what we have to see here.
Sir, what is the best book for reference for thermodynamics, sir?
For the questions only, gate point of view, I think a textbook only conventional type of question mostly would be there. So previous year is the best thing, I think.
Okay, sir.
So I think we can start with second law.
Sir, here is volume is as pressure is written to be directly proportional to volume, but sir P1 V1 is not equal to P2 V2. Then sir,
That's
how
why
to deal with
I
that?
want to say you na, you cannot go with that way. Here they just said like this pressure. Okay, 1 minute. So that's why I said only you have all values here. Initial volume you are having, final volume you are having. So don't try to stick to the formula. That's why I want to say. Go from basic. Basic is what you know: initial pressure and final pressure, and make the diagram and area under PV curve. That is the most basic thing. Here, if you are having value, then why try to stick formula? In formula, lots of assumptions are there actually.
Sir,
It is not saying like it is completely reversible process. It is ideal. Then only you can use formula.
Sir, are you going to provide all these questions to us?
What?
Are you going to provide all the questions to us?
This slide I would say I will be sharing. Slide I will share. Okay.
How you get?
In one drive I will share, and that link I will put in the chat box. Okay.
Okay, 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 sir. Thank you.
So today I will put date here, and second law of thermodynamics we will start. So 29.8. So can anyone first thing is this, why it came into the picture? Okay. First law is what? What is the first law?
Conservation of energy.
Conservation of
Conservation
energy.
of energy, sir. Energy can be neither be created not
Means del
destroyed.
Q is equal to delta U plus delta W. That will be right. But I will say like we will give means delta U for a fixed process, like this is the process, fine. This will take as 1, this will take 2. So delta U will, for a process would be the fixed, right? Means within 2 points. Is it okay to not or not?
Sir,
Yes, sir.
could you please repeat it once, sir?
I will say like first law, what is the first law? Del Q is equal to del U plus del W, right?
Yes,
So
sir. Yes,
for
sir.
a process between 2 points, delta U is fixed. Okay.
Yes, sir.
So it means like whatever amount of heat we will give, and in same way it will convert it to the work, right? Let's suppose
Work done.
we added 80 kilojoule heat, and then let's suppose for a process delta U is here 15. Okay, for this 1 to 2 plus 15. So for this way this work would be how much?
30.
65, right? Hello.
Yes, sir.
Yes, sir.
Yes,
Huh.
sir.
So this is 65. Now coming to the like more, we will add heat, and same way in proportional way, only apart from this internal energy, we should get heat where work means for this law what we are getting, whatever heat we are trying to give. 1 minute. This is the, let's suppose, process.
Yes, sir.
Here
It only occurs in only one direction.
1 minute. So with this what this will tell like this will say like both things. You can add work, heat will increase, means okay, getting according to work. Only here quantitative things we can get to know, like this way, this much heat we will add, so this much work will happen. And same opposite also can, this much work will happen, this much heat we should give. This we can say, right?
Yes.
Yes, sir.
But actually now opposite you can think also, the like mm, 1 minute.
Sir, for refrigeration, would it be opposite? Like, are you talking about it?
No, that's not answer. So I'm saying like if we add 15 kilojoule of heat, so how much you will able to get the work, that's I'm saying. Like for
Okay.
this law you will be getting like 15 kilojoule heat you are giving, then you have to
Hmm.
get 15 kilojoule of work. That's what
Huh.
my point.
That is not possible because heat
That is
is
not
low
possible.
grade of
That's
energy.
why second law it came into the picture, na. So, and the direction
Yes,
also
sir.
don't know we, like
Yes, sir.
with this
Hmm.
conservation of energy we have to know like.
Yes.
Mhm. So that's why how much loss is there, means how much work heat is not going to convert into the work. Hmm. So one thing we came to know, why this we don't know the direction, by the first law don't know.
100% conversion is also not possible.
That's what that I will prove how it is not possible. Don't know the direction of process. Okay, and means which way is feasible, means let's suppose 2 points are there. Some pressure temperature is here, P1 T1, and some pressure temperature P2 T2 is here. Okay, now you want to like you have filled some and pipeline is in between. So now how you will come to know, like you know the for this condition you are having, you can easily get like how much work would be there, how much heat transfer would be there, right? With the formula you are having now for ideal gas, you consider you can transfer now.
Yes.
Yes, yes.
But whether it will transfer from plant 1 to plant 2 or plant 2 to plant 1, that you can let me know or not. Only quantity you can let me know na, this much work will happen, this much heat will be transferred. Okay. Getting what I'm
And
saying?
the
Yes, yes.
reaction with the help of second order.
Hello.
Yes, sir.
And you are getting what I'm trying to say?
Yes, yes.
So this is the main problem, because you know the quantity by the first law, but what will be the direction for that, that we don't know. So with the that's why if you know you have this plant, let's suppose this where is the cursor? You are having this plant, so you have to find now which direction you have to which direction it will be fluid is going to flow. So first you have to know the flow direction, then only it is valid how much work is there, how much heat transfer would be there, and how much loss is there, then only that those things come into the picture, right? So in any
Sir,
question,
now I got it.
so in any question first you have to find the like what is the direction for the process, means it is feasible or not. huh? That also we will see like how it is feasible or not. First we have to find the flow, and then we will apply the first law of thermodynamics, means this conservation of energy, etc., everything.
Physical or not means what?
Feasible,
Feasible.
physical not.
Process is feasible or not, that I'm saying.
Feasible, sir.
Feasibility of the process means feasibility things may not be clear yet. What is the feasibility here? That after 20 minutes we will get to know like what feasibility I'm talking about. Okay.
Thank you, sir.
So so why thermodynamics, the second law of thermodynamics come into the picture, that you got. Okay. Now coming to the two three things. One is the heat pump and heat engine and refrigerator. These three words everyone know or not? First, let me know.
Yes, yes.
Yes, sir.
Anyone don't know can raise hand. Okay. Okay, then I think everyone knows.
No one, sir.
Okay, okay. Someone has raised. So,
Sai Prakash.
mhm. So heat pump. These three are devices. Okay, this keep in mind. Um, let's suppose one example. This is temperature T1, and this is the device, and this is the temperature T2. So for the we will start from the heat engine. Okay. Engine whenever you listen the engine words replies means like you are getting something, like engine what engine does, you are getting some work there, you putting diesel etc. And generator you have must have seen. In generators what we used to do, put kerosene and rotate and get some energy there, so it gives us work. Engine is a device, with there we give some type of another energy and converts and gives back to us. So here what will happen, one would be the source, one minute, source and sink, and from source means it is a high energy, matlab a high temperature source will uh, consider it as. So and reservoirs reservoir, no, what is reservoir?
Yes,
Sir,
sir.
where the energy
Yes,
would be
sir.
stored
No, 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 no.
to supply.
Temperature.
Infinite heat capacity.
Reservoir means like sea. In sea, you consider 2 3 buckets of water, nothing happens to you. Reservoir is the same thing. From there, if you extract something, some part of energy, its temperature and energy capacity won't be decreased. Okay. So reservoir means that. So it is reservoir at temperature T1, means its temperature is not going to decrease when you are taking heat something from this. Okay.
Yes.
So its temperature will always remaining as T1. So source means high energy, means it is a high energy state, source means. So and the sink and some part of energy get released here at lower temperature. So it's also reservoir at temperature T2. Reservoir works at both ways. Means you extract heat, same temperature would be there. You reject heat to that one, same temperature would be there. So Q1 heat coming to this is the our device. You put this into mind. This whole is the cycle. This whole work as the cycle, and device our heat engine is in between only.
Sir, reservoir means energy storage, sir.
Energy storage, like a pond water is there, and the Lindsay water is there, like that. So it is a reservoir for energy. Means energy would be there, but it won't be decreasing. How much you will try to extract.
Sir,
So
what is the example of a reservoir?
like you can consider for the
Water tank.
what?
So I'm taking as an example of reservoir would be water tank. Whenever we require water, we open the tap
That is the
or faucet.
layman example. For the heat, you can think of like
No, actually, I am asking heat engine. What is the example of a reservoir? Because the sink will
for
be the
the conceptual purpose.
atmosphere.
That I'm saying. For the conceptual purpose, we used to take as this as the reservoir. Temperature won't be decreasing. But generally, what happens na? Here is a body of some heat capacity, but its temperature keeps on somewhat decreasing also. But what? Let's suppose here we have put uranium, right? And some
Yes.
reaction won't be happening here, and heat capacity or energy storage is very high here, right? Like we are having 1 gigawatt is means you are taking. So what mass rate you are putting for the uranium here, in it would be in the gigawatt system, right? So you are extracting heat, let's suppose in some kilojoules, 1 kilojoule. Relative to 1 gigawatt, 1 kilojoule is nothing, right?
Sir.
Gigajoule you can consider here. Let's suppose that you have dropped that time dependence here. So that's you can consider as a practical example. Okay, got it or not?
Yes, sir.
So
Sir, got it.
सर रिजर्वायर का केवल टेम्परेचर कांस्टेंट से रिलेशन है या फिर उसको ये भी माना जाता है कि एनर्जी कंटेंट भी चेंज नहीं होगा?
If there is no change in the temperature, and then if temperature change is not there, so energy would be the same. Okay.
Sir, but for pure substances like two phase are coexisting, then it may be considered as a reservoir, sir.
Actually, voice is breaking. What are you saying?
Sir, a two phase coexisting substance.
Very less voice is coming actually.
Two phase coexisting substance. Two phase coexisting substance, sir.
Then
सर उसको थर्मल रिजर्वायर ट्रीट कर सकते हैं कि टेम्परेचर तो सेम रहेगा, बस एनर्जी कंटेंट चेंज होगा.
Okay, you are saying about this means in between that liquid vapor this area you are saying.
Yes sir, yes sir. Energy content to change.
Here so at some point of time things would be changing na. You are keep on extracting heat. Let's suppose here it will come after that. This point of things will keep on changing na. Here property should not be changing with time. Okay.
Okay sir. Okay sir.
Okay then. So where are we? What is the heat engine? Heat engine is a device which is used to produce work. Okay, to produce work. Now coming to the heat pump. Here what happened? From high temperature source we have reached to the low temperature source. Our device accepted heat from the high temperature and rejected heat from to the lower temperature. Got it? Hello.
Sir.
Yes, sir.
Yes,
Got
sir.
it.
So now coming to the heat pump. Actually main confusion is in between heat pump and refrigerator. So this you must have keep in mind. Actually main error also would happen here only. So we will consider this as T2. This is device T1. Here also T2 device. So what happens heat pump? Anyone can tell?
Goes from higher to lower.
Sir, lower to higher and higher, sir.
It takes work and produces higher heat
The
energy.
T1 heat goes to that T2.
Actually, refrigerator we all know.
Sir,
It produces
Everyone
heat
homes
energy.
refrigerator is there. We will start. So what
sir, it
refrigerator does?
will refrigerators are maintains the temperature lower than the atmospheric temperature.
Surrounding. Okay. So
Hmm.
means it will. This is refrigerator. Refrigerator. What refrigerator does? We used to give some electric power energy to it, right? And it
Yes.
will work, and it extract in some enclosed area is there, so it will extract from their heat. Q1
Hmm.
refrigerator is
Yes, sir.
extract heat from cool places, cold place
Yes.
only, right? Cool area, cold place, anything we can write. Cold place, and rejects to the higher temperature, Q2, right? So what is this Q2 according to
Yes,
first
sir.
law?
Right.
Q1 plus W. Here also what would be the work done? Q1 minus Q2. Same thing now coming to here. What heat pump does? Heat pump maintains the temperature uh, above the surrounding temperature, right? Hello.
Yes, sir.
Yes, sir.
Refrigerator is a device which is a work absorbing. First definition, if you have to write like this way, you can write refrigerator is a device which maintains the surrounding temperature, uh, which maintains the temperature below the surrounding temperature by absorbing some work, by taking some work. And heat pump also, it is a work absorbing device which maintains temperature at a place more than the surrounding temperature. So in cold times means
Hello, sir.
huh, hello,
Sir, screen is not visible, sir.
hello, huh.
Sir, your screen not visible.
Oh, is it
Visible, sir. It's
this to
visible.
everyone?
Sir, it is visible.
Hello,
Hmm.
screen is visible or not?
No, sir.
Yes, sir.
In my case, it is
It's
visible.
visible, sir. It's visible, sir.
Yes, sir. In my case, it is visible, sir.
Then I think network issue would be there. Okay, can disconnect and join again, I think.
Network issue.
Sir, I have a
Yes,
question, sir.
sir.
Mm-hmm.
Visible, sir, now.
Sir, if we keep the refrigerator outside of room, like in a normal place and open place,
Mm-hmm.
what it would be? Would it cool all the things, or like would it be in
What the
normal
pressure
temperature,
cooled
like
place is the inside the refrigerator. Okay, this is the T1.
inside, like no, the condition is like it is an open place and the door of the refrigerator won't be closed, it would be open, then what it would be happen? Because
Nothing will happen. It will be cooling the things. If its capacity would be cooling capacity more than the means what energy is coming inside, uh, then only it will.
okay, sir.
It has to extract heat that time also. And
Okay, sir.
It
from
is
the back
not
side it would
possible
be.
to. It is not possible to cool a open place because that requires a lot
Lot
amount
of
of heat. मतलब what?
whole surrounding that have to be.
And yes, sir, yes, sir. And the compressor would be
Compressor
compressor
capacity won't be
produce.
that much
Uh, yes, sir. Please repeat it again, sir. Please.
because compressor, what compressor does? Compressor
Com-
only VCRS you that actually that thing will go into that RAC part. That because that's why I want to go there. What
okay.
any cycle you have read yet?
Yes, sir.
I
Yes,
think
sir.
this thing we can discuss after the class also.
Or not, sir.
Okay, sir.
Okay, sir. Okay, sir. Continue your class, sir.
So heat pump we maintain just for the that theoretical use. You can take down these definitions. Like heat pump is to maintain the temperature above the surrounding temperature, work absorbing device. This much only. Okay.
Okay, 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 sir. Yes, sir.
So here Q1 would be there and Q2 is there. So what is the refrigeration effect? Two things you have to know. Here you know work done, right? Because in engine you are going to get work. What is the work done? Q1 minus Q2. Okay.
Q1 minus Q2.
and here you are getting cooling the things. So what is the refrigeration effect here?
Q1.
Q1. And what is the energy you are giving to the system? Q2.
W.
Energy
W.
W. So here we are heating the things, right? So here heat effect we will write He. What is the He
Yes,
here?
sir. Q2.
Q2 would be there, okay?
Yes, sir.
So Q2 would be there, and what work done you have given? It is the W. So in engine efficiency is coming into the picture here. What is the efficiency? Anyone?
Output by input.
Output by input, yeah.
This way we can say also. So W net and input is what? Heat given.
Q. Q supplied. Q1.
Q in. So what is the W? W net Q1 minus Q2. So
Q1
this
minus
way you can
Q2.
arrange things. Q1 minus Q2 by Q1. Here Q1 I have written. Q1 by
Q1.
Q1 Q1 1 minus Q2
Q1.
by Q2. Right?
Q2 by Q1. Yes, sir.
But efficiency will always be in between 0 to 1. Right?
1. Yes, sir.
Actually, here I have made mistake. 1 also
This
work.
efficiency is for refrigeration.
That's
Refrigeration.
that's why I now I'm coming to there coming there. So so let's suppose this is Q2. Okay. So now if here you are going to what is the means efficiency what you have to write what you used to write here, whatever the your desired output that would be here, and what is the input that you write down below this
Yes, sir.
means desired output, and here energy input. So for the heat pump, let's suppose heat pump, what is the desired output? Q2, right?
Sir,
Q1
which temperature is greater, T1 or T2?
T2 would be
Okay,
for
okay.
heat pump. So for efficiency, let's suppose for efficiency purpose we are going Q2 by W, right?
Hmm.
So what is the Q1? Q1 plus W by
Q1 plus W.
so it would be the more than 1, right? It is visible easily.
So coefficient of performance
That's why coefficient of performance came into the picture. Yeah. Here for the heat pump and
Where it
refrigerator.
is less than or greater than 1, sir?
That's why
No, for
efficiency
heat,
of heat
for
pump when you try to find what is the efficiency? Efficiency is like what is the desired output and what is the energy input. That's why you are trying to measure the efficiency. Okay. Desired
yes,
output.
yes.
What for heat pump? What is the desired output? Q2.
Q2.
And what is the energy input? W. So
W.
if you in efficiency in the terms of efficiency you want to measure the heat pump. So what would be that? More than 1. Now concept of
Yes,
efficiency is
sir.
what? It should be less, in between 0 to 1. Huh?
Yes, yes. That's why CA2 came
That's
into
why
picture.
we given new word like COP, coefficient of performance. Means its value how much its value from 0 to in from starting from 0 to from whatever it wants. So now coming to the COP. What is the COP? Desired effect.
Coefficient of performance.
That COP means okay, that I will coefficient of
Performance.
performance. So desired effect by energy input that you keep in mind because we used to write like learn like desired effect by work input, energy input. So work input you consider then in when RAC you will read vapor absorption cycle. There work is not nowhere we are going to give work. Only heat is as a input energy we used to give. So heat you cannot consider as work. So energy considers both. That's why energy input is more important. So desired effect for now coming to the
Yes,
COP
sir. Yes,
for
sir.
uh, COP for refrigerator. Refrigerator. So So for the refrigerator, what is the desired effect here?
Q1, sir.
Q1.
Refrigerator. So for the refrigerator, it is Q1 by W. W is what? Q2 minus Q1. Correct? Hello. Hello.
Yes, sir. Yes, sir.
Yes, sir. Yes,
Yes,
sir.
sir.
Yes, sir.
So same thing, COP for the heat pump. What is the desired effect there?
Q2.
You want heat
Q2.
pump, right? At high temperature. So Q2 by work done would be the same, Q2 minus Q1, right?
Yes, sir.
So now if the, let's suppose two things are there, same temperature differences, T1 T2 is same, and one is the heat pump, one is the refrigerator. What would the relation between the COP of both? Because you know now,
Please,
Q1 Q2 you
Heat
have to
pump.
just
please,
eliminate.
please, once repeat the question, sir. Please.
If you are having the like refrigerator and heat pump both working in between the same temperature limits, T1 T2 is same, so what would be the relation between COP?
Okay, sir.
Getting or not what I'm
Let
saying?
me.
Sir, I cannot understand the question.
Yes, sir.
I'm saying let this temperature T2 and this is device and this is the T1, this is the Q1 and this is the Q2, and this is some device, okay, and work is there, work is how much? Q2 minus Q1, correct? So let's suppose
Yes, sir.
for the first case it is a heat pump, and in second case it is the refrigerator. So COP for heat pump you know, and COP for
COP of
refrigerator you
heat
know.
pump is equal to refrigerator plus 1, sir.
Yes,
Q2
yes.
by Q2 minus 1.
So here what is the COP? Q2 by
Q2 minus 1. Sir.
Q2 minus 1. Here what is? Q1 by
Q1 by Q2 minus 1.
Q2 minus 1. So I'm saying like what is the, in terms of COP, like I will say COP of the heat pump for the working in between these two temperature is 5. So what would be the
Huh.
COP of refrigerator? No other data I have given.
It will be 4, sir.
4, 4,
How
4.
you came to know that? That I'm saying.
That's
Because
COP of
Difference
if
of
we
both
if we
COPs is equal to 1, sir. Difference of
sir if we
COPs of heat pump and refrigerator is 1.
Like what is the COP of heat pump? Q2 by Q2 minus 1, and for the refrigerator how much it is? Q1 by
Q1 divided by Q2 plus 1. If we add 1 on right hand side, then we will get Q2 by Q1.
okay. Now if you add 1 here, yeah,
Sir, I think on right side, sir.
yes,
Right side add.
1 plus. So now you will like same thing will come, right? So what is this?
Sir.
COP of heat pump is equal to 1 plus COP of refrigerator. Correct? So this is the
Yes, sir.
one
Yes, sir.
basic formula you have to learn. Now coming to the Kelvin Planck statement. What is this? First statement you know, let me know. I will go ask you just significance. What is this? What it says?
Sir,
No engine works.
heat cannot completely
Efficiency of a heat engine cannot be.
going to work.
Means you were saying like what here it is, and
It cannot work on single reservoir, sir.
heat cannot means for this if Q1 is there and you must have get output as Q1, right? This is the Kelvin Planck statement. For this, what is the efficiency of the system?
100%.
100%.
Pardon me, sir.
100%.
Could you please repeat it again, sir? Actually, my internet is not working properly.
Actually, I am saying what is the Kelvin Planck statement? Kelvin Planck statement is like this: energy cannot be sorry, we cannot produce work by the one thermal reservoir. One thermal reservoir means another thermal reservoir is not there. Means
There is
whatever
no
work we are
sink.
giving to the system, whole would be converting to the work, right?
Yes, sir.
So for this, no heat rejection happens. Means work done is also Q1 and heat given energy input also is Q1. So efficiency would be 1. It cannot be 1.
100% efficiency.
It cannot be 1. It is by the Kelvin Planck statement. Okay.
Mm-hmm.
So with the Kelvin Planck statement, significance is there that for any work producing cycle, in efficiency can never be 1. Means 2 reservoirs should be there. It would always be less than 1. That's why I removed this. I removed here also. First I put this, but it can never be 1. Now coming to the what is the Clausius statement? Just I'm not going to deep into that. Just what is the significance?
Without aid of external force, external energy, heat doesn't transfer from a cooler body to hotter body.
It means like if you generally what happens from higher energy state to things without any giving any work, from higher energy state things try to come to lower energy state, right?
Yes, sir.
So now things at the lower energy state, let's suppose this is Q1, okay, and this is
Sir.
the higher energy state Q2, and this is some work absorbing device WA. So it is saying like if you there cannot be any device which is possible in which we will not give any, sorry, where we will not give any
External
external work.
work.
This is work. This we will not give. This we will not give, and it is possible like we transfer this heat to this heat. Thi- okay, without any external work. So what is significant COP? Then what would be the COP of this system if this is possible?
Infinity or
Infinity.
not defined.
Infinity.
So some effect would be there. Tension effect would be there. But here it was 0. So with the Clausius statement, what is there? COP can never be infinite.
Hmm.
So
Not exist.
Clausius Kelvin Planck statement is for the work of producing device and its efficiency can never be 1. And Clausius statement is like it is for the work absorbing devices and its COP can never be infinite. Okay, quickly we go. Now coming to the Clausius inequalities in you have studied, I think.
Yes, sir.
Before this, I think I put the Carnot cycle. So, what is the Carnot cycle?
To isothermal and isentropic process.
First of all, it is the highest efficiency process.
Highest efficiency
I,
cycle.
ideal cycle. Ideal cycle.
Yes, sir.
Both processes are ideal and reversible, and any cycle working between two temperature limits, it is having the highest efficiency. That's all. Correct or not?
Yes, sir.
Yes, sir.
Sir.
So, what are the processes here actually?
Two reversible isothermal and two reversible adiabatic
Yes.
process.
Irregularity.
So for this, actually for this TS diagram is very easy for this, right? Just one box. What are the which processes? Because same numbering we will do, and it should be the for if the work producing cycle it would be the
Sir,
Q1.
it would be rectangle or a square.
Huh? Hello.
It would be rectangle or a square, sir.
This depend on you, na. How much you want to make. Like if a process you want to make long, this
Depends on the data.
it depends on you, na. What you want. It is not like
Exactly. It
how
is for
what amount of heat you have given, what amount you have heat you have exchanged. This
yes, sir, yes, sir.
so this 1 to 2. You name the process. Okay, I will just quickly write. Okay. What is 1 to 2 process?
Isentropic.
What is the next?
Isentropic
What is the
process.
next?
Hit. Yeah,
Reversible
Entropy would be the
adiabatic.
same.
Isentropic compression.
What is happening here?
Compression, sir.
Temperature increase isentropic compression.
Okay.
Sir, network issue, sir. Sound not coming properly.
From my side, it
Yes,
is
sir.
also.
Sir,
Hello.
it's fine, sir.
I think.
Fine.
Okay. So in PV diagram, actually, this what I made, why I made this, I try to make here. So it would be the four pro. Actually, I will make quickly. So here you just let me know which process is which. Let's this is, where would you do one? Let me. Anyone?
Sir,
So
this
first compression are there, then heat addition, then expansion, then heat rejection.
sir,
So once
the curve which is higher slope is isentropic process. The
Higher slope
curve
is
which is
isentropic. I am saying about which
yes.
corner is one point here.
Keep corners ABCD, sir. Then let us decide.
Huh?
Right post.
So right,
Keep corners
right,
ABCD.
top right.
Corners.
This one you are saying.
Sorry, left, right. Sir, left, top right.
Left and top. This one you are saying.
Yes, sir. This one is there.
This one is one you are saying. Huh? So
Yes, sir.
according to this one, and what is happening? Temperature is low and you are compressing it. Correct.
No,
Yes,
sir.
Yes, sir.
So where it is happening
yes, sir.
compression here? Yes, and its cycle would be like this. Okay. This way you have to do.
Sir, right bottom is the starting point, sir.
And this one you are
Yes,
From
saying.
sir.
where it starts compression. Yes, sir.
So which process is
There
this?
is,
The
Isothermal process
left
is this.
bottom, sir.
sir.
Now it came to mind. This is
Yes,
isothermal
sir.
and this is
The
isentropic.
isothermal followed by the adiabatic compression, sir.
So here first what I did, isentropic process is there.
Isothermal expansion. Sir, first will be isothermal expansion.
I am asking about your point here. Which point is first?
Okay, sir.
No, not about what is the process. Let's
Sir,
suppose
that point will be
Okay,
one,
this
okay.
sir.
would be the
That's the
first
middle
one.
one, sir.
Yes, sir.
First,
That
yes,
point.
sir, yes,
That
sir.
point will be one,
That
sir.
will be.
And from here
Yes, sir.
isentropic compression is there. S is equal to constant.
Hmm. Yes, it is like in TS diagram 1, 2, 3, 4. That will be like
Same way I
in
am
PV
asking.
diagram.
What would be the first point? That you have to know because in IC engine then you got confused no from how to start. 1, 2.
Yes, sir. Sir, yes, it is in the TS diagram.
Same way. Okay. So here what is the efficiency? Actually, let's suppose from here it is Q1 and here it is Q2. Here we are given, let's suppose we have given work in compression W1 work we have given T1. Okay. So it is cycle.
Yes, sir. Sir,
So
dear.
Q1 minus Q2 is equal to W1 minus W2. Okay. That would be there, right?
Yes, sir.
So efficiency would be what? 1 minus Q2 minus Q1.
1 minus T2 by T1.
No, I am going from
So you
basic.
can write in terms of absolute temperature, 1 minus T2 by T1.
Okay, that will come. How you now for the that Carnot cycle, you used to write efficiency as 1 minus T2 by T1. Can anyone let me know how you converted Q2 to T2 here?
Sir, as it is a ideal gas, so we use the formula of MCVDT.
Okay. But in refrigerator, etc., never we never actually use that. Huh? Here, in one concept is there, like concept of absolute temperature scale. There we assume like heat transfer is function of temperature. Hmm. Like Q.
Uh,
So function of temperature. Oh, and for the simplicity, just we take as the linear variation. Otherwise, this variation here, heat is the quadratic, anything would be there. So for the simplicity, just we take Q is directly proportional to T, just like that's why it is there. Okay. So it is not like that.
So it is only for
And if
reversible
someone
process,
want
no?
to make the question trickier, then he will change this. So that time Carnot efficiency will got changed for that cycle. Okay.
So please repeat it again for that condition. Why Q equal to T?
I said like for the ideal gas, means ideal cycle and ideal fluid also there. Everything is there.
Mhm.
So, ideal, then Q is the function of the temperature of that body,
Temperature.
that place. So for
Okay.
that simplicity, it is the function of this. So it would the directly proportional to temperature. Huh?
Huh.
Means not temperature. It is the function of temperature. The function could be anything, na? Any power would be there. Anything is there. So for just for the sake of simplicity, we'll take like Q is directly proportional to the first power of the absolute temperature. For,
Absolute temperature. Yes, sir.
it is just assumption for the Carnot. That's
Mhm.
why
Mhm.
Q2 we it directly proportional. So constant got eliminated here. So
So
in
therefore, it would be linear in graph.
that's why it
That
is just
that.
we replaced it Q2 with T2 here. And
Yes,
in
sir.
if
Got
someone wants to make question like tough and it will change. So they will say like it is quadratic. So some relation they will give. That time it's formula got for the Carnot it will change. But you go for this only till as of now. If nothing mentioned, then you have to take this.
So it is only applicable for reversible process. One
Carnot is
wants to do
reversible.
what you.
Carnot first word is it is a reversible cycle. If you are coming to Carnot.
Yes, sir.
So whatever other cycles efficiency we will say like it's 50% of Carnot cycle. Likewise. So you have to first calculate the Carnot efficiency, then that 50% we have to take for that cycle. Okay. That same question we will do. No, don't worry.
Question, sir.
What? Hello. Anyone saying anything?
Sir, what would be this process?
Your voice is not coming actually.
Sir,
Some microphone issues from your side, I think. Anyone can able to hear? I think I'm not
sir,
able to
why
hear.
3 is not a work
No,
producing
no,
process.
no. He
Yes,
is
sir.
not audible.
Mm,
Sir, process 2 to 3 is why not work producing.
what?
Process 2 to 3 is not work producing. Why, sir?
Acha, that you are saying here. Process 2 to 3 is not where? In this cycle, you
Uh,
are saying this one. You are saying, na?
sir, in P1 PV diagram.
PV process 2 to 3 is not work producing. Is that you are saying?
Yes, sir.
This is isothermal
So
process.
this is reversible heat addition. Isothermal heat addition.
Actually, why we say like Q in only here?
So heat
For
converting,
isothermal,
not
what
heat
you knows?
producing.
Heat addition is also there. In isothermal formula, you don't have studied like what is the work input for work for the isothermal. Knows or not?
Yes,
Yes,
sir.
sir.
So here work interaction is there, but I mentioned only Q in because in these two processes 1 to 2, 3 to 4, there won't be any heat interaction. Correct? Hello.
Yes, sir. Please repeat, sir.
I said like there won't be any heat interaction from 1 to 2 and 3 to 4 because it's a reversible adiabatic process. So no heat interaction would be from these two processes.
Sir, can I tell something, sir?
Uh-huh.
Sir, as isothermal processes are process in which the piston has to move very slowly, no, sir.
Uh-huh. So this is
Because it
no
is
problem for
that's
you.
why we can't achieve the work, no, sir.
Uh-huh.
Can we say like that?
What?
In isothermal process, the piston has to move very slowly, no, sir. We-
Mm-hmm. But at the end
That's
of process,
why
we would be having some amount of work. Okay.
next to that process only we can attain the work, no, sir.
Mm-hmm.
After completion of isothermal process only we are achieving the work done. So that we can say that as the piston moves very slow, the work is not up from the process, no, sir. I was said like
So
that,
some
sir.
work
That's
interaction
why.
is there. I would say like so for the total
Yes, sir,
cycle
but that
work,
is
you have to
negligible
consider
in
all
that case.
four process work here. You
Ah, yes,
cannot
sir.
neglect anything.
Yes, sir. That's why as it is slow and it is so much negligible in the case when compared to the isentropic process work done. It was negligible, I'm saying. Hello?
I'm able to
Are
hear.
you getting? Are you getting me, sir?
Actually, now when you try to find work done from 2 to 3 and 3 to 4. Huh?
2 to 3
4 to
work?
1.
No, sir.
2 to
Actually,
3 and
the
4 to
work
1.
is actually I was studying in our thermodynamics class that in the isentropic process we take work done because as work as the process going on in isothermal process, the piston has to move very slowly, and the due to which this case the molecular interaction will be very slow. That's why the work getting from that process is very negligible compared to that of the isentropic
Comparison,
process.
if comparative we are taking, then magnitude wise also it is very less. Yeah.
Yes, sir. Yes, sir. That's what I'm saying, sir.
But okay, you neglect if you want to neglect that, then we can. But in practical way, I think for all four processes work we have to consider. In any cycle we
Practically,
used to
this
take.
cycle is not possible, no, sir.
Huh?
Practically, it is not
Practically,
possible,
whole
no, sir.
Carnot cycle is not possible, no, actually.
Yeah, yes, sir. Yes, sir.
So this
Yes,
is a
sir.
theoretical concept only. That I'm saying.
Okay, sir.
So, sir, then will Q1 minus Q2 equal to W1 minus.
Um, okay, that I think I made this mistake here. Okay, you have to consider here also work interaction would be there also here also. Work interaction is
Oh,
also there, but we usually put Q1 because heat interaction is from these two sides. That's why. So we can take this as W1 minus W2, and this also we can take. This one is how much? Means net work done you have to take. Okay, like this
sir, okay,
you
sir.
can write W net. So if you are considering only work, then all four processes work we have to calculate. But in in terms of heat, you have to take only two processes because in these two processes no heat interaction is there, right?
Yes, sir. Yes, sir.
Like that way you have to. Okay. So now coming to main thing is here. Clausius I am saying, no? Clausius inequality.
So how can we say that if the cycle is clockwise, then it is work producing, and if it's anti-clockwise, then it's work consuming?
Any cycle any work producing cycle when you try to make that will only clockwise, no? Because area under curve like okay, 1 minute. Let's suppose this is the cycle. Okay. Hello.
Yes, sir. You're
Yes,
Yes,
sir.
sir. Yes, sir.
So let's suppose first is it is the clockwise 1 2 3 4 this way. So delta V is the same here, and this one is the P1 and this one is the P2. So for the for first 2 to 3, here work done from 1 to 2 is 0, to 3 to 4 is 0, right?
Yes, sir.
So work W net how much? From 2 to 3. So what would be there? P2 and delta V, right? And
Yes.
this would be the area under this much hole, this thing is, right? And now we will and now what would be the from 4 to 1 to 4 minus P1 delta V. This minus you right able to get how I put minus here. Hello.
Yes,
As
sir.
as it works upon it, so therefore you put minus.
So
Is
fine
that
actually what we have to write final volume minus initial volume. Final volume is less means final point is 1 na. So getting or not?
Yes, sir. Yes, sir.
So here delta V is now positive, P2 is more, P1 is more. So what would be the W net? Positive here. Getting or not?
yes, sir? Got it.
Now same make this cycle as anti-clockwise now. This way. Now let's suppose this is P1, this is P2. Now what would be the more? This one would be negative, right? Upper side now. One, four. Now what would be the W net? Negative or positive?
It would be negative, sir.
Sir,
So
what is that word positive?
what? Hello, anyone saying anything? Okay, so for the clockwise, this is positive. Positive work net means you are getting the work from the cycle, right?
Hmm.
And for the negative work done negative means you are giving the work done to the cycle, means a work absorbing cycle.
Hmm.
So which one is work absorbing? Anti-clockwise, na?
Anti-clockwise, the negative one.
So anti-clockwise would be the work absorbing devices. Work absorbing cycle means heat pump, refrigerator, etc. These type of things will come into this category. So and heat engine clockwise cycle will come into this. Getting or not? Whoever is saying asking this question.
Yes, sir. Yes.
Okay. Okay. What is the classification of equality? Anyone quickly?
Integral of QIT less or equal to 0.
Means for any process, cyclic integral of dq by t would be less than equal to 0 for the all possible cycles. Correct?
Yes, yes.
So three
Hmm.
things would be coming here. If cyclic integral of dq by t, sorry, cyclic integral dq by t is less than 0 means, and
Irreversible process.
Increasing.
cyclic integral of dq by t equal to 0, what would be there?
Equal to 0. Reversible process.
Cyclic integral of dq by t greater than 0. Then what? It
Greater
means
0.
this is ideal, most ideal case would be. Huh? Then it will be there. This is the
Hmm.
practical cycle. Practical means some loss would be there, etc. Anything. So this we will see how loss is happening. Practical and what is this?
Impossible cycle.
Impossible. Now can anyone prove how this is happening? Means is some practical. That's why I first spoke about the Carnot, because more than Carnot anything cannot anything happen. Huh? This you keep in mind. So we will take one example here first. Let's suppose this is the 600 Kelvin, and this is the some device what we will put here, and this is 300 Kelvin. Okay. Let's suppose we are giving 300 joule of energy here, and here is the heat engine. So for the Carnot, what will be the Carnot efficiency for this? Can you? Actually, I am telling what is the what is this these equations shows. Ah, you can learn anyhow. Efficiency would be 0.5, right?
Yes, sir.
Hmm. So maximum work, what maximum work you can achieve from here?
150 joule.
You can maximum you can get 150, right? And this much would be how much then? 150, right?
Yes,
Yes,
sir.
sir.
So now this would be the Q1, and this is the T1, and this is the Q2, and this is the T2. Can now you quickly calculate in cycle two things are happening. One, first it is receiving heat Q1 at the temperature 600, right? Temperature is not changing with time here. Reservoir we are taking. So and here what is 150 heat is going this reservoir at 300 Kelvin. Then what is the cyclic integral of dq by t? Quickly tell. Means heat given system is our heat engine. So heat given to the engine is 300. Heat given to the system is positive, right? Getting or not what I'm saying?
Yes, sir. Yes, sir.
So 300 by 600 and heat rejected by the system is 150 minus we will take here
150.
150 by 300. How much it will be coming?
Total efficiency would be
No,
like
not go for efficiency now. Now I'm asking to calculate cyclic integral of dq by t. Means
Zero.
in process
0.
inequality, what is this? Dq by t is a cyclic integral dq by t. This is Clausius inequality, na? What would be this? Less than equal to 0. This we have to. This is going to be c. So for this, what in this cycle we have considered? Ideal cycle. Considered or not?
Yes, sir.
So cyclic integral dq t by t is coming to 0. Now let's suppose practically you will never be getting like 150 joule work, right? Hello.
Yes, sir.
Yes, sir. Yes, sir. Audible.
So let's suppose you are getting now 100 joule of work. This is a practical cycle.
Someone voice is disturbance, sir. Voice disturbance is coming, sir.
Turn off mic everyone actually. So what would be the Q2 now? Quickly response. If 300 joule is heat is coming to the heat engine, 100 joule of work we are getting, then what would be the
200.
Q2? 200, na? Because
Yes, sir.
300 is coming, 100 is going out, then 200 would be coming here, right? Hello. If you are not getting, you can tell me.
Yes, sir. Yes, sir. Yes, sir.
Yes, sir. Your voice is audible.
Yes, sir. Yes, sir.
So then what will be the cyclic integral for this? This is for the ideal process. Ideal. Now cyclic integral of dq by t for the, this is the practical cycle, right? Because here work done is less than 150. 150 is the maximum we can get. So what will be the dq by t for practical here? Means 300 by 600 minus 200 by 300. How much it would be coming now? Minus
-1/6.
minus something will become
Nine
minus
number six.
0.1667 like that I think. Not so. Okay, this will come, right?
Yes, sir.
So for practical, what we have written here, cyclic integral of dq by t would be less than 0, right? And for
Yes,
the
sir.
ideal this is. Now consider one impossible cycle. Impossible means maximum we can get 150. Now consider you are getting 200 joule of work. Then here how much it will going? 100, right? Hello.
Yes, sir. Yes, sir.
Yes, sir.
Yes,
Yes, sir.
sir. Please.
Continue. Continue.
Then what would be the dq by t here for the impossible cycle?
One
Means
by six.
300 by 600 minus 100 by 300. Means something in positive it will come. Correct or not?
Yes, sir.
Yes, sir.
Yes, sir.
So this is the meaning. Means what is the what is the practical sense here? Less than 0. What is the ideal? What is the impossible? So this way you can think of. Means practically you can appreciate this way. This Clausius inequality. Okay. So means Clausius are now coming to the. Sorry. No, Clausius inequality is clear, na? Hello.
Yes, sir.
Yes, sir.
So
Yes, sir. Yes, sir.
now simple thing we will say like entropy. Entropy is nothing in theoretical word you can say randomness of degree of randomness you can say.
Molecules.
Degree of randomness of means how randomly molecules and etc things are moving, that we can say. So one entropy principle is there. Anyone know? means total entropy of the system plus surrounding means universe. Delta S of universe is always more than or greater than equal to 0. Correct? Means in whole universe either entropy, most ideal thing will be happening, then entropy would be the constant. Otherwise entropy of the whole universe will keep on increasing. In the universe what things are coming? Delta S of system plus delta S of surrounding.
Sir, where is this extra energy coming from? As whole universe की randomness increase कर रहे हो तो मतलब energy आ रही होगी कहीं ना कहीं से, तो extra energy आ कहाँ से रही है?
वो कुछ नहीं है. And any energy you are any extra energy is coming here.
It's
Is there
just
any
converting, sir.
nothing na? So same thing is
It's
happening
just
here.
converting.
So something is at lower temperature, something is a higher temperature. Let's suppose same thing is you are putting at lower temperature, means it's molecule moving slowly, and same thing you are putting at the higher temperature, molecules would be running at a very high speed. You haven't put any energy, you just put the place the things from one stage to another state, nothing more than that. So that same thing will happening here. So you are not adding anything, it is just the game of the state where it is happening. At some lower temperature pressure, higher temperature pressure, just change of state, things will happen. You are not putting any extra energy, so that's why because everything has its capacity, so according to that things will happen. So don't go in that much deep actually.
Uh, Sir, to change the state, we need some energy.
No. If you, let's suppose one reservoir is there at some temperature and another one is at another temperature. So same thing, same energy has its capacity, some capacity at means capability. Some energies have its capability at capability of doing work. At this temperature is different and the same temperature is different. That is their entropy. Actually, first finish this thing. Then after some doubt is there, then you can think.
Okay,
Okay.
sir. Okay, sir. Okay, sir.
So after that, if you think, then I can, you will relate more, I think. That's why, because a lot of things will come as of now. So in universe, system plus surrounding, two things would be there. So now coming to the but now coming to the like surrounding we left, if system is there. Now keep in mind for entropy of both system plus surrounding, that would be the more than equal to 0. For the system it may like anything. System, it may be greater than 0, less than 0, or equal to 0. Anything can happen for this na. This thing will take care other thing if you, but summation would be greater than 0. Correct? Many times in gate they will ask for the entropy of the system may increase, decrease, sorry, less than 0, greater than 0, equal to 0, or any of these. So getting what I'm saying?
Sir, sir.
Any of
Yes,
these.
sir.
Any of these may happen for the system. You have to keep in mind these things. So for the surround universe, it will always increase. Means more than 0, greater than or equal to 0. But for the system, it may happen anything. So you can take some examples for that. For the system, two things may happen. Here, two things may happen.
Sir, your voice is not coming.
Hello, coming or not?
Yes,
Not,
coming, sir.
not. Yeah, now coming, now coming.
Yes, sir. Now you are audible.
Okay. So entropy of the system is part of two things. In system, some internal irreversibility is there. ITR we will say. Internal, sorry. Okay. And one is the external irreversibility. Internal irreversibility. So internal irreversibility means some system is there. So inside the system, due to viscosity and etc., or some loss mechanism is there inside the system. So that will take care of these type of irreversibilities. Okay. So this we cannot control. Delta S of uh, internal irreversibility plus and delta irreversibility due to external, sorry, EXT. Entropy due to external irreversibility. External irreversibility means this is the system. Let's suppose some heat is we are adding here. So due to addition of heat, some entropy would be there. Okay. So what is this? This is dq by t. This we can calculate actually. This thing so we cannot calculate. Okay. Hello.
The delta
Yes,
S
sir.
for the system is equal to delta S IT.
In ITR means internal irreversibility. Internal irreversibility means due to the properties of those system itself, those irreversibilities are coming. So those we cannot eliminate actually. So those would be there. Okay.
Okay.
So let's suppose system
Sir,
is
IAR means
irreversibility. IRR irreversibility. Pura completely I haven't written. So now coming to the like system is internally. First example take like what would be the value of delta S system? You take you quickly do. I will ask the question to you this. Okay. Now this formula keep in mind. Let's suppose this is equation 1. And now question is what will be the entropy of the system when the system is completely reversible. System is internally reversible. Hmm? So at that time what would be the entropy? Hello.
Yes, sir. That will be
Yes,
dq
sir.
by
Yes,
t.
sir.
That time dq by t. Let's suppose this is the system. Now from in the system you are adding heat. So heat added to system is positive. That time if this is the case then delta S system is positive, right? Put here TQ is positive, T is always positive, delta S system would be positive, correct?
Yes, sir.
Yes, sir.
And second case heat rejected to the rejected by the system, same system. That time it is negative, right?
Yes, sir.
Yes, sir.
Heat rejected by system negative we take, na? Hello.
Yes, sir. Yes, sir.
Yes, sir.
Audible.
Now coming to the next system, it is isolated.
Yes, sir.
So Q would be 0 here now. Then delta S of system is 0.
0.
Hmm?
Yes, sir.
Now second case you will take now delta S of system when it is internally irreversible. Hmm?
Yes, sir.
Now delta S system delta S this part would be 0, not 0. Got it?
Yes, sir.
And it is adiabatic. Hello.
Yes, sir.
Yes, sir. Yes, sir.
Audible now?
Yes, sir.
Audible. You are perfectly audible.
So then delta S system would be same this equation 1, right? Now here one case is like whole adiabatic, everything is adiabatic. So what would be the delta S now here ds and means what I'm saying. This is the system and this is also adiabatic. Means surrounding also no interaction is there. Got it? This is the system.
Yes, sir.
So with one thing, what I put here, delta S universe. This surrounding delta S surrounding is now 0 because no interaction from surrounding with due to this insulation. Okay,
Yes, sir.
Sir, so
and
here
Yes.
this system is also insulated. So this part also now 0. Getting or not?
Yes, sir.
So now ds of universe is what? Delta S of internal irreversibility. But internally irreversible now. It is written here. Getting or not?
Yes, sir.
So delta ds universe is delta S of
Irreversibility.
irreversible, internally irreversible. So ds universe is always greater than 0, right?
Yes, sir.
So what came from here? Like delta irreversibility due to internal irreversible always more than 0. It is concluded from here or not? Delta is due to internally irreversible process, internally irreversible always greater than 0, right?
Yes, sir.
So this keep in mind one thing. Now coming to the mm, delta S of system is what? Delta S of internally irreversible plus dq by t. Let's suppose some part is here, but heat interaction is also going on there. So
Yes, sir.
it is positive, correct?
Yes, sir.
But same way system is made in that way, like it rejects heat. Means if you are giving heat, then it is also positive, so no sense. But it is rejecting heat, let's suppose. So Q is negative now. So you have set the system like that. It is the negative, but in same value. Getting
Yes,
or
sir.
not? So then
Entropy will
also delta S of system is 0.
0.
So now you have got two ways to make a system entropy 0. One is here adiabatic. What? Because here we have what we have said, internally reversible. First case, internally reversible. Said na here.
Yes, sir.
So internally reversible and
Adiabatic.
adiabatic. So this is isentropic. Isentropic. Isentropic means entropy is constant. One is uh, internally reversible plus adiabatic. And next thing for isentropic what is? It is internally irreversible, means irreversible we will say irreversible process plus
Yes.
heat rejection.
Yes, sir. Sir, in the upper case, we can say that reversible adiabatic.
Same internally reversible you are saying that then means it is reversible.
Yes, sir. Reversible adiabatic.
Reversible adiabatic also isentropic and irreversible plus heat rejection process is also isentropic. Now what
Yes,
in
sir.
theoretical question they ask, like only in only reversible plus adiabatic process is isentropic process. So this option this is wrong na, then because this way also you can get isentropic na? Getting or not?
Yes, sir. Sir, but the second case will possible when both value will both magnitude of both value will be equal.
Ha. That's why I said na, you set the value of q this way, this is same way in it is negative to this one.
Okay, sir.
So these two things to keep in mind. Now the you can derive the formula, because now I'm not going to write this, because just only write this formula. I also written those formula before also. Change in anyone knows the change in entropy is the function of three formula we will write. Okay, entropy is a
Yes, sir.
function of pressure and temperature. Entropy is function of
Pressure,
pressure. Sorry, temperature and volume.
temperature and volume,
And
pressure and volume.
okay, apart from you, anyone knows?
Yes, sir.
Okay, tell.
Sir, first for pressure and temperature, it will be delta
Cp
S equal to
ln
T
Cp ln T2 by T1 minus R ln P2 upon P1
Quickly write everyone if someone is there also.
minus R ln P2 upon P1.
Formula.
Second, Cv ln T2 upon T1 plus R ln V2 upon V1.
ln v2 by v1.
V2 upon V1.
This one?
Cp ln P2 upon P1. Cp ln
No,
V2 upon V1.
cp ln
V2 upon V1 plus Cv ln P2 upon P1.
plus
Cv
here what plus
ln
or minus?
sir plus sir
cp ln
P2 upon P1.
okay, quickly write these three parts. After that, I think entropy theoretical part is over, but now question part will come. Those tricky question actually.
Yes sir, yes sir. Today itself question part will come.
I think we cannot do much question because already we have at 9. But I will give question to you, and if someone tries, then try. Then otherwise, in next class, I will directly start from questions and take 36 7 question like that. It means
Okay, okay
most
sir.
of the question of the conventional side.
Okay, sir.
Those will consider most of the part from the entropy. Hmm? So question,
Okay,
I think
okay.
I should written na those formula. Okay, first question is this. Screenshot you can take and try because I think now you will able to relate like a reversible heat engine operating between reservoirs 800 and 330 degree. Engine
Uh,
it is there and upper temperature. Convert this to Kelvin first. Okay, keep in mind.
yes sir, yes sir.
And it drives which and next this engine giving some work and reversible which operates between okay one something is missing here. Later we can do reversible refrigerator. Okay.
Yes sir.
Reversible refrigerator which operates between this temperature limit, then heat supplied to the engine is okay, heat supplied to engine they have given, and network output is 290. What network output means here, whatever engine produced and then whatever you have given to the refrigerator, after that what is there, this is, so then you have to find the cooling effect and total heat transfer to 36 degrees Celsius reservoir. So I think I should give hint to you for that, and then you can try after in the home you can try, right?
Okay, okay.
So there it is asked like it is 800 degrees Celsius and reversible it is said, it has said. So all thing cannot you can take. This is the heat engine. This is 30 degree. Convert this to Kelvin first, huh? And this they have given 1900. So you can just find by the efficiency you can get. Okay, find the efficiency first, not efficiency. Then what would be the work from this produce, and then this heat you can get. Now some refrigerator is there. It is working between 15 degrees Celsius. It is 30. So some heat is extracting this one. Okay, this one we will give a say Q1. This one we will say Q2, and this one we will say as Q3, and this one we will say as Q4. So they have given here. Let's suppose here W1 is there and W2 is there. So W net is W1 minus W2. This you know 1900, right?
No sir, 290.
Okay, okay, 290 is there. 290 is there. So you have to find here Q3 and Q4. Okay.
Yes sir.
So try give a try to this and yes.
Sir, please sir, previous slide. I have to take screenshot.
This slide.
This slide sir.
Take and then I will give one more question and two questions you to try. After that
Okay
we
sir.
can do next.
Sir, please make it big. Okay, sir. Okay, sir. Thank you.
So another question. Another question. You told us to you will give us two
Wait
questions.
and wait. This is one question. Uh, Here, what I already said, like it is reversible cycle. Okay.
Yes, sir. Yes, sir.
So work done net work done from this cycle is 1000 kilowatt. This is given. Then you have to
Yes,
find
sir.
the QB and QC, and here we also don't know what is the direction for QB and QC, right?
Okay.
Yes, sir. Yes,
Here
sir.
it is going from 300 to from the to QB is towards the heat engine, and this hint I can give you. First, you suppose like QB is this way and QC is this way. Then what is the W net? What is W net? This is
Q1 Q1 minus Q2 Q1 plus Q2 minus QC.
I
QA
can give you
plus
some data also. No, no, no.
निरंजन भाई जब नहीं बोल रहा
Hello.
hello.
I think I have missed one data here. Okay. So let that I will check and tell you. You can try this question. Efficiency you can find it. Same question is there. Here that way I think I forgot how much heat is coming. So here work net we are knowing, and this 1000 kilowatt we are giving from 600 Kelvin. So same way you have to find here also. First you have to find this how much heat is going from this this is
Sir, can I take the first question screenshot, sir? I didn't.
you can try. I think I am thinking like I am missed. Maybe it is wrong. This is a complete question. So you can try this because here first we use the energy conservation. I will give hint and then you try. Energy conservation use. With energy conservation, what you can do? Let's suppose Q dot we will do because watt is here. So W net is 50 and this is coming 1000 from this is Q1 na QA use. So 50 heat given to the first QH input incoming to the system means 1000 positive, and QB Q dot B is into the system. So this is also positive, and QC is outside the system. First equation, right? Any doubt here?
No, sir.
No, sir. No, sir.
And the next reversible engine we have said. Na? What whenever we said reversible, then dq by t cyclic
Equal to
efficiency
0.
will be zero. That you have to take.
Yes, sir.
So zero means what we will say entropy principle. So this is zero. First 1000 by 600. Are you getting or not? First wait for
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
plus and heat given to the system for the B Q dot B is by 400 and this is minus 1000 by 300. So this way two variables and two equations. Take care of the sign. Try to do. You will get Q dot QC QV values from these two equations and do here and find the efficiency of the cycle. How will you find W net by heat input Q dot N, right? Then you have to take the care of the science which heat is coming to the system, which is going out. Getting or not what I'm saying?
Yes, sir. Yes, sir.
Other doubt?
Sir, why can't the direction of QB be opposite, sir?
You take first QB is opposite, then take here negative and
So
here also negative.
it is given in the question.
No, no, nothing. I just for giving the hint to you. We have to start from something.
No, I'm asking, will it be given in the question?
Nothing. Question never gives you.
Okay,
You have
okay.
to take care of. If you have considered negative, then in the answer it will minus sign it will come.
Okay, sir.
Huh? You give a try. I have given hint. So next class I will start from these two questions, and I will try to ask you from you. Means whoever did try to what answer is there. Okay, values I will ask you.
Sir, next class when it is?
I used to take on Monday only. Monday, 7 to 8.
Okay,
Actually,
okay.
official time is 7
Next
to 8, but I used to take.
next Monday, sir.
Each Monday.
Sir,
Okay,
please
okay, sir.
drive link, sir.
Hello.
A drive link.
I'm not getting what you said.
A drive link, sir.
Okay. First, I have to put that link I will share, and in that link I will upload soon. In half an hour, I will upload.
जब नहीं बोल रहा हो तो
Okay, whoever is having that drive link, then they can leave. Otherwise, I will share in the group.
Please share, sir.
1 second. Someone has put up. Okay, I have given a. See,
Yes, sir. Yes, sir. Yes, sir.
and listen. Also, when I used to forget the start recording, last next class try to remind me if I will start.
Okay, sir. Okay.
Because
Sure, sir.
actually, what happens now? The same recording is going to upload. Wait, yeah.
Mm-hmm.
Thanks.
So try to early uploading the recorded
Going
statement
soon because last week they also asked for recording. I think that this week they will.
so that we can watch.